All right, so today our objective is that I can explain the causes of changes in climate locally and worldwide. Okay, so some natural processes that change climate are volcanic eruptions, ocean circulation, solar activity, and Earth's motions. Okay, so a volcanic eruption. The presence of volcanic ash, dust, and aerosols in the air increase the amount of solar radiation that is reflected back into space. So volcanoes erupt and they put a lot of soot and ash into the air. And what does that do to the air? Two things that come to mind. Pollute, that's the first thing I would think of. And what's coming from the volcano? A lot of what? Smoke, ash, soot, so that's polluting, but what else comes out of the volcano? Lava, okay? And so that's real what? Hot. Okay, so that's putting what into the atmosphere? Heat. Yeah. Okay? So this causes Earth's lower atmosphere, the low atmosphere, to cool, because even though you have this hot lava, okay, a lot of times the smoke, the ash, the dust, that is what covers, and it gets real dark. And so therefore, nothing's going to get through. So then there would be cool air above. Next is ocean circulation. So El Niños, these causes parts of the eastern tropical Pacific Ocean to become warmer than usual. So arid places receive large amounts of rain. Places that receive lots of rain may experience dry periods. And here there are wet summers. Okay? La Nina, okay, surface temperatures in the eastern Pacific are colder than average. Okay? El versus La, warmer, colder. Okay, hurricanes damage greater in La Nina times, and here there are dry summers. So the big difference is El Nino, okay, wet summers, warmer than usual. La Nina, colder than the average, dry summers. Those are the big pieces there. Next is solar activity. This is the formation of sunspots that appear to correspond with warm periods in Europe and North America, and these run on an 11-year cycle, okay? And last piece of this is Earth's motion. So we've talked a little bit about this, orbit and tilt. So Earth's tilt causes the seasons. We've talked about this, we talked about rotation, we talked about revolution, and the change in the degree of the tilt, okay, or shape of the orbit could cause global climate changes. So that's going to take us into our next piece. So human impact on climate change. So this is something we've already talked about. I told you that a lot of this stuff is going to come back from the last unit. So the greenhouse effect. We talked about the greenhouse effect in here. Who has ever been to a greenhouse? What's in the greenhouse? Plants, right? And what does it feel like when you walk in there? It's hot, right? Okay? So when you walk into there, it's super hot. And the reason is because the sun's rays come in and they get trapped in there. And then they start bouncing around and then it heats up the greenhouse. Well, that greenhouse effect is what's happening in a greenhouse, but it actually happens in the atmosphere, okay? So it's a natural warming of both Earth's lower atmosphere and the surface. It makes life as we know it possible. The major gases that deal with this are water vapor and carbon dioxide. We talked about carbon dioxide a lot with this. So excess carbon dioxide, excess CO2 that gets put into the air, that's one of the reasons that we have the greenhouse effect. Okay, humans have added more greenhouse gases to the atmosphere in the past 200 years, and this is by burning fossil fuels. Remember when I drew that goofy picture on the board? Does anybody remember what it was? fossil fuels come from? One of the places. Remember, I told you I'm not an artist. I wish that were a cup of coffee. A factory, there we go. It's pretty terrible, but you got the idea, right? We're not winning win, lose, or draw here. So a factory puts a lot of these into the air. Driving a car, burning gas, that puts these into the air, okay? Methane was another big one that deals with agriculture. That puts this into the air. So these are all major contributors to climate change. So the biggest piece is global warming. So as a result of increases in CO2, as well as other greenhouse gases, global temperatures have increased. And we've seen this picture before, okay? And at the end of the day, this affects both weather and climate. So it affects day-to-day stuff, but it also affects over time, over years. So the natural greenhouse effect versus the human-enhanced greenhouse effect, and I don't know if you were here this week or not, but what do you see that's different between those two? Natural, human-enhanced. What are some things that stand out? Three things. What do you see up there? All you're doing is looking for the differences between the pictures. Oh, that's a good specific look at words. Beautiful. Okay, so that's one. So in human enhanced, less heat escapes into space, but in the natural, more heat is escaping. What else do we see? Two more. Yep. Less re-emitted heat versus more re-emitted heat. Okay, so going back in, there's less re-emitting. On the human enhanced, there's more, and then one more. What's one more thing you see? More greenhouse gases in the human enhanced side, because we contribute a lot to greenhouse gases being put into the atmosphere. Okay? All right. Next is the temperatures rising due to global warming. So the effects of this, and you're going to see this a lot, glaciers melting. Okay? Greenland, if all of the ice melts, oceans will rise 23 feet. The Antarctic, major reduction in ice coverage, because if we have heat, what's happening to the ice? It's gonna melt, okay? And then the permafrost in the tundra, which we talked about the tundra yesterday, is releasing CO2 that is stored under the ice. So now what's getting put into the atmosphere? More CO2, okay? So glaciers melting. If all of the ice melts, then oceans are going to rise. Antarctic, there's a major reduction in the ice coverage, and then the permafrost in the tundra will release the CO2 that is stored under the ice when it starts to melt. Okay, so the hottest year since 1980, the Earth has had 19 of its 20 hottest years on record. Okay, so we start down here all the way at 1997, most recent 2010. So Antarctica, where do we find Antarctica? The pole, right near the pole. Okay, so if all the ice in the glaciers of Antarctica melts, then this takes us back to the piece where the oceans are going to rise. Because ice is what? Solid. When it melts, it becomes what? So it's going to do what? Take up what? Take up more what? Yes, it'll flow up once it melts, right? So the ice is solid, so it only takes up so much space, but then when it melts and becomes liquid, it's going to flow all over because it's going to rise. And that liquid is going to essentially be taking up more space in a different way. Okay? Does anybody have questions?